Now, it is my privilege to introduce Shri Amit Saxena, a distinguished scientist E at C-DAC Pune.
Yeah, thank you so much. So this is going to be the last talk, and I would like to summarize the activities. We are working in a symposium of quantum and AI because we are working in a group quantum in AI. So this symposium is being conducted by Artificial Intelligence and Quantum Technology Group at C-DAC Pune, and in collaboration with DIET. So I will just briefly tell you of the activities of the group that we are doing, and there are many more activities. This is a newly formed group in C-DAC Pune, and what activities we are doing currently and what activities we are planning forward. So, and under the leadership of Lakshmi Kanat Madam, she is our program director. So as you know, C-DAC is known for Param supercomputers. Without these images, any presentation of C-DAC is incomplete. We started with Param 8000, we started with Param 10000, that were all in Pune University, and this legacy we are taking forward. And Param was the supercomputer which introduced cluster computing. Now at that time we were denied this vector supercomputers, Cray. Cray were based on vector supercomputer technology. But now you can see, Param was based on cluster computing. But now you can see, all the supercomputers that are available today are basically based on cluster technology. They are not vector. Vector and mainframe are gone. Okay. So this is how we take the legacy forward. This is under National Supercomputing Mission. We have established various supercomputers from Param Shivai, Param Shakti, Param Brahma, Param Yukti to Param Smriti, and then from Param Utkarsh to Param Siddhi. That is in Pune. That is the #1 supercomputer in the AI petaflops. So we have Param Siddhi, and now we got Param Siddhi Airavat. So that is at C-DAC Pune. With this, we start with the quantum computing. It is based on the superposition, entanglement, and tunneling. I think you all know basics of quantum computing is a qubits. So these are the various products that we have developed in C-DAC. QSIM is a product that has been developed by C-DAC in collaboration with IISc and IIT Roorkee, and this is available. If you type qctoolkit.in, you can access it, you can use it, and with a Gmail ID you can access it, and you can start working on the various algorithms that are available. You can work on Grover, you can work on Shore. The maximum capacity is up to 12 qubits to 18 qubits, depends on this performance, and then it is very good tool for learning on a quantum simulator. Okay. Then we have this in the quantum communication. This project is working, that is drone-based QKD, we can say. Okay. So this is a free space communication-based project that we are working. Then we have a fintech quantum safe financial transaction framework. That is basically for the financial transaction, how to save by using this QKD. Then we have HPC-based quantum accelerator project, which is a project by 5 centers of C-DAC. We have C-DAC Patna, C-DAC Noida, C-DAC Hyderabad, C-DAC Bangalore, and C-DAC Pune. And under this project, we are developing testbeds, various testbeds that are being used for simulating quantum computers. GPU testbed, vector testbed, FPGA testbed, and then we are also putting all these testbeds, and we will do benchmarking of this activity. And then finally, it will be available through a quantum experience center, and we call it like Q Universe for the people to access. Soon we are going to launch the Q Universe for the public, like QSIM is available. Now, with all this, we are moving forward with a HPC and quantum integration system, like hybrid quantum computing system. We call it HPC quantum integrated. And the left-hand side, you can see Param Q. This is a concept, and soon in maybe 1.5 years, we will going to have a quantum computer at C-DAC in the range of 100 qubits. And we are soon going to integrate it with the HPC system, that is our Param systems, and we are going to have a HPC quantum integrated hybrid systems. So we are working towards that. This is how we are going to solve these problems. You can see that when we say HPC and quantum, the problem are same. We have the problem that is artificial intelligence based things, drug discovery, optimization, cryptography, financial things, and there are like flood prediction, weather predictions. Those are the problems that are grand challenging problem. It can be solved by classical right now, but you can see classical, we are moving toward the exaflop systems. Now the exaflop systems, they need huge power requirement. Now can we do it with a HPC and quantum integrated system in less power requirement? So that is what we are trying to see. And as Vishal has already mentioned, we are working on the open quantum systems. We want to develop all the quantum computer that is following an open quantum ecosystem, and then with the HPC hybrid integrated system. So that way, we want to work in solve the grand challenging problems in the AI-based things, drug discovery, optimization, cryptography, and financial service. So these are the various applications. Actually, our main target is why we develop Param supercomputers. We wanted to solve some problems. These are the real-life problems that we want to solve. And now, to solve this problem, can we use HPC? Can we use quantum? Can we use HPC quantum integrated both? Or can we use another form of computing that we are targeting? So now our group is working on the AI-based activities. So these are the AI oncology based systems. So these are the various projects that we are working. We'll see one by one. So eye oncology is one of the systems where we have developed a web-based EHR system for cancer, Proforma, and this is a machine learning-based prediction model for the mammography-based things. Then we have developed IUsoft, that is a software-based fundamental, which is based on the fundamental principles of Ayurveda. So we have Ayurvedic principle. Based on that, the software can help the Ayurvedic practitioners to really find out diagnostic and holistic approach. So the IUsoft is a vision of converting classical Ayurveda text into comprehensive, authentic, and intelligent interactive knowledge repositories. That is a software in a total available. Then we have this mobile-based surveillance using IT. So this is like any type of disease surveillance can be prevented by using AI methods. Then we have this Chitrankan OCR-based Bhashantar translation system. So this is how it translates. Then we have various success story of this. We have deployed it in Uttar Pradesh Vidhan Sabha, and we are using it in various other departments. This software, it is in a production mode. It is working. Then there is a speech synthesis software which is also being deployed at various places. This is a recently project we have got, agriculture, AI in agriculture. So this is with a collaboration with IIT Indore. Professor Aruna Tiwari was here. Tomorrow she will talk about this, and this system, this project was launched on 27th recently by our Secretary, Ministry of Electronics and IT. And this is going to develop an agriculture-based hub which will support the farmers, breeders and ICR institutes by using AI technologies. So these are some projects that we are working, and we are interested to collaborate, to work with projects in AI and quantum computing. So these are the highlights. Thank you.
As we conclude day one of the symposium on quantum computing and artificial intelligence, I would like to extend my heartfelt gratitude to all our esteemed speakers for their invaluable insights and contributions. Your expertise has truly enriched our discussions and set a strong foundation for our exploration of these transformative fields. I also want to thank our audience for your active participation and engagement throughout the day. We hope you found the session informative and inspiring. Please join us tomorrow as we continue our journey diving deeper into the realms of quantum technology and artificial intelligence. Have a wonderful evening, and we look forward to seeing you at 9 a.m. tomorrow, bright and early. Thank you.